We're going to look at a few questions dealing with angle properties in triangles right now. So we're going to focus on determining sum and measure of angles in a polygon, in a triangle in particular, and understanding the types of angles in the polygon. So here's a multiple choice question dealing with triangles. For which triangle does the third angle measure 35 degrees? Is a triangle ABC where angle A is equal to 65 degrees and angle B is 85? Is it a triangle DEF where angle D is equal to 35 degrees and angle E is equal to 110 degrees? So in other words, that would be angle F we're looking at. Triangle GHI where angle G is 50 and angle H is 100 degrees. So is angle I going to be 35 degrees? Or is a triangle JKL with angle J equal to 75 degrees and angle K equal to 80 degrees? So is L going to be 35 degrees? Okay. What you have to remember about a triangle is that the sum of all three angles in a triangle is always going to add up to 180 degrees. Okay, so when we're doing a question like this, what we have to do is determine how many degrees are left over. If we know two angles and we know the sum of all three, we can determine what's the missing angle. So for triangle ABC, to find angle C, which is the missing angle, it's going to be 180 degrees minus angle A, which is 65 degrees, minus angle B, which is 85 degrees. So I put that into my calculator. I get 180, subtract 65, subtract 85. And that means that angle C is going to work out to be 30 degrees. Now we want one that's 35 degrees. So triangle ABC is no good. How about triangle DEF in option B? I'm looking for, in this one, angle F. So again, the sum of all three angles in any triangle is 180 degrees. So what I'm going to have to do is start with 180 degrees, subtract from it angle D, which is 35 degrees, and subtract from that angle E, which is 110 degrees. So I put that into my calculator. And angle F works out to be, look at that, 35 degrees. So B is going to be the answer. But I just want to check to make sure that the other ones definitely don't work as well. So in triangle GHI, I'm given triangle G and I'm given angle G and angle H. So I'm going to be looking for angle I. So angle I is going to be 180 degrees minus 50 degrees for angle G, minus 100 degrees for angle H, and that's going to also work out, if I put that into my calculator, to 30 degrees. So once again, that's not going to work. Now how about triangle JKL? Angle J is equal to 75 degrees, and angle K is equal to 80 degrees. So angle L is what we're missing here. So I take 180 degrees, and I subtract from that 75 degrees, and I subtract from that 80 degrees. And 180 minus 75 minus 80 in my calculator works out to be 25 degrees. So angle L is going to be equal to 25 degrees. So angle F in triangle DEF is the only angle that is 35 degrees of my options here. So that is the correct answer. Okay, my next question here asks, what is the measure of each interior angle in the isosceles triangle? And in order to do this, we're going to need to use a protractor. Now what you can't see is that I'm actually putting a protractor on my computer screen as I'm doing this video. And I'm measuring angle A first using the protractor. I make sure that the center line of my protractor is on the vertex A, and that one of my one of my rays of that angle, which I'm using AC, goes across the bottom of my protractor along angle 0. And when I do that, I find that angle A is going to be equal to 40 degrees. I'm going to do the same thing for angle C. I'm going to put my protractor up against it, make sure that the center of my protractor is touching the vertex C, and that ray AC is, or line segment AC is also along the 0 degree line in my protractor. And once again, I get a measure of 40 degrees. And lastly, I'm going to do the same thing with angle B. Once again, I've got my protractor up on my computer screen, and my center line of my protractor is on vertex B, and I'm using AB as the line segment that the 0 degree line of my protractor goes through, and it gives me a value for angle B of 100 degrees. And when we know that the angles in a triangle add up to 180 degrees, that makes sense, because 100 degrees plus 40 degrees plus 40 degrees, that adds up to 180 degrees, which is exactly what I expect. Okay, so which angles are equal to each other? Well, we know that we have two angles that are 40 degrees each, so angle A and angle C are both 40 degrees. So they're the ones that are equal to each other. So now we have to classify each angle as right, obtuse, or acute. So angle A, I'm going to do a little table. I got angle A, angle B, and angle C. So angle A is 40 degrees. Is that right, obtuse, or acute? It's between 0 and 90 degrees, so that's going to be an acute angle. Angle B is 100 degrees. So that is an angle between 90 and 180 degrees, so that's going to be obtuse. And angle C is also 40 degrees. It's the same as angle A in measure, so it must be the same type of angle. So that's also going to be an acute angle. So question D asks, how many of each type of angle does the isosceles triangle have? Well, we have for acute angles, we have 2. For obtuse angles, we have 1. And the only other option is a right angle, but we already used up all of the angles in the triangle. So we have 0 right angles in this triangle. So there we go. So to summarize this, an acute angle is an angle between 0 and 90 degrees. A right angle is exactly 90 degrees, and an obtuse angle is between 90 and 180. We can classify our triangles based on the types of angles they have. If all 3 angles in the triangle are acute, all of them are less than 90 degrees, then we call it an acute triangle. If we have 1 right angle, the other 2 must be acute. It's always going to be the case where 2 of our angles in our triangle are going to be acute, and it's the third one that we concern ourselves with. So if we have 1 right angle, we call it a right triangle. If we have 1 obtuse angle and the other 2 acute, again, there's no other option. 2 of the angles have to be acute in the triangle. Then we call it an obtuse triangle. We can also classify triangles in another way with regards to their angles. If all the angles are different, we call it a scalene triangle. If we have exactly two equal angles, then we call it an isosceles triangle. And the example we just looked at was an isosceles triangle. And finally, if we have Three equal angles. We often refer to a triangle with three equal angles as equilateral because all the sides are the same. But we can also call it equiangular. That means that all three angles are going to be the same. And whatever triangle you have to remember that the sum of all angles in a triangle, all three of them added together, is always going to equal 180 degrees. It never fails. Always 180 degrees.